you're looking for the axis, okay, the ellipse. But also, if I've drawn these ellipses properly, this is the paradox, is that although you're looking at something that's going away from you in space, and the hub or the centre of the circle, which is an ellipse is a circle in perspective, the centre of it might be there, you know, the smoke's coming off, etc., etc. So it's moving away in space. But this line here, which describes the axis of the ellipse, and is also the centre line, you know, the one that goes through the middle of the ellipse, one half of the ellipse should be folded onto the other. If this was cut out of a piece of paper, the ellipse is always a symmetrical shape. Okay, so have you spoke about that?
No.
Okay. So you're looking for two things. First of all, you're going to draw your ellipses so that they've got that symmetrical quality. You know, what often happens is people make the back of the ellipse, so they're drawing the wheel of the bicycle, and then it'll sort of come out like that because they're assuming that that back edge will be flat. Okay, and this will be more curved. But in reality, what happens is it's always, if I've drawn it correctly, that half there is equal to that half there. It's the mirror reflection, if you like. Okay. So the explanation for this paradox is using the same model that you might have seen drawing a square, which is we draw our square. This is always, whatever you're doing when you're drawing a square in perspective or straight on, you know that that's the centre of the square, those two diagonals. From that you can then project these two lines, and this is probably one that we spoke about, is that one? Where you join the,
yes.
You know, the square is going to hit on those 4 points. So it follows that you can draw that square in perspective and you draw the circle in perspective. But my addition is to do this and say, if you take the halfway point for all of these, which can actually be established by reasons of doing that, you've already got that diagonal in place, and the same on this one. I don't expect you to do this, but it's a way of doing it, particularly when you're drawing perspective, which I'll show you in a moment. So it follows that that goes through there. And that, if that's correctly drawn, they should all look like that. We've now got these additional points here to work with. And if I join them up, this is my invention, I now draw that shape in space and it explains the paradox. So now I'm going to draw that square in perspective. It doesn't matter how I do it. Okay, I draw the diagonals in that I started with. That now tells me where the centre line is, which is much further towards the back of our shape. And in fact, if I project these out, I can now project down through there, and that gives me the central point. Okay, so I've now drawn that part. The next thing is, and again I can do the little divisions. I want it. And project out through there. Should come down, that's right. Yeah. That one there. I'm not expecting, I mean, you can do this drawing if you like, just as an exercise, but I'm certainly not expecting you to do this when you're drawing bicycle wheels, but it's to explain what it is that you're looking at. So now we've got these points that I was talking about. Now this isn't mathematical, it's a visual, okay? I'm not trying to hit you with the... I only just straight to the third level maths, so I'm not pretending to give you the kind of the mathematical model, it's just a visual thing. Okay, so now I've drawn the template for my ellipse. And there's the ellipse. If it's symmetrically drawn, the halfway point, you know, where I can divide that ellipse will be just there. This should fold, if it's drawn correctly, it should fold onto this. And it is not, that's the centre line there. Okay. So I'll just do another quick one of those on this one. So I've changed, I'm now looking at the square from a different angle. This centre line is always going to be parallel. Okay. So now I'm not going to go through the whole thing of drawing it up. You can just see this, the halfway point for these the orthogonals will be slightly further towards the back, and here they'll be pretty well in place. 1, 2, 3, 4, 5, 6, 7. That's in place. So now there's my ellipse. And you'll notice when it's off-centre it gets a slight tilt to it, so that axis will not necessarily be lined up with the shape of the square that we've drawn. It goes through there, so that this part here should fold into that. The centre of the circle, which is, say, the spokes of the bicycle, is back here. So I can draw my axis in, there's the spokes. Alright, so this model is to explain the paradox. So I'll do it once more, and this is the important bit to absorb from what I'm doing here. That. And this is something you can do with a cup of coffee in your hand, you know, sitting in the dining room or the kitchen or wherever. Now, where's the coloured chalk? So you can, before I draw it, you can see that the back half of the circle is indeed much smaller than the front half, just as the back half of the square is much bigger than the front half of the square. And of course what I've given myself is quite, here they're very subtle points. That's my phone, so I don't turn it off. Here I've got much blunter, you know, much sharper points, but when I draw my circle into that, basically it's coming up and touching here, and, you know, it's almost like this is a piece of wood and I'm chopping off the corners, a bit like the geometric shapes I was recommending for drawing the figure. So the centre of our bicycle wheel, which I've now drawn as this kind of, whatever shape we'll describe that is, not a circle yet, the centre is way towards the back, but the ellipse that fits into this shape that I've given should, right, keep it inside. Okay, now that's gone out, so it's going to more like it. And an ellipse is not an oval. An oval is sort of straight and then has curves at the other end. This is a continuing curve. All right. So the point is this: that given that original model where your circle is only touching these 4 points, that's really the only place where it's touching. Okay, there, and those 4 points. But because of the perspective, it continues beyond that point. Okay, it appears to be touching the line. In reality, it's just touching it at that point, and then it's sweeping around, and it's just touching it at that point. But visually, it appears to be sort of riding along that line with a very gentle curve in it, and then suddenly it turns when it hits that corner. Does that make sense? So that's the point of contact there. But what happens is that because of the perspective that's occurring, it appears to keep on going outwards to follow this other shape that I've drawn. Okay? So I would recommend that you do try and draw. This is pretty easy to do. And draw your squares in at some stage. Another thing you can do, and I'll talk about this later when we start applying it to the architectural models, you can do it in the vertical, and so far I've been doing the horizontal one, I'm going to do it in the vertical, which will correspond more to bicycle wheels.
How do you determine the centre of the ellipse? The centre line of the ellipse when you jump?
This one here? Yeah. By literally
by eye?
Going from by going from the widest point to the widest point. Does that make sense? And when you draw the bicycle wheels, you know, here they are here, whatever they're doing, you're looking for the highest point, furthest point to the top, furthest point to the bottom, and that will give you the axis. And actually there's another axis that goes through it like that. And the bicycle wheel has the advantage that it has a hub. It's transparent, you can see through it, but it has a hub, which will be here. But that's the centre of the ellipse. The hub is going to be over here. That will be the hub. Okay? So you're looking for two things. You're looking for the centre of the circle, and you're looking for which is this, and then you're looking for the centre line of the ellipse, and they will not coincide. So that's the centre line of the ellipse, that's the centre of the circle, and that's the important bit. So does that explain why a circle seen in perspective appears to be symmetrical? Does it explain